that model, it will display the project here. Okay, it will display the, you can rename that, suppose model, you can rename that. Okay, model analysis, this is your project, you can rename that also, you can rename that also, project. Okay, now you observe here, this is just, you can take the multiple projects. Suppose you want to do the static structural analysis, right? So it will be displayed here with tree as A for the model analysis, B for the static structural. Okay, so in this graphics user interface, you can perform or you can do n number of projects. Or suppose your project is too large, it is consisting of a number of subcomponents, right? In case of IC engine, suppose, so you want to evaluate the separate analysis of every component, as well as suppose combine analysis. So you can save that project with IC engine, you can do the analysis of pistons and okay, then crankshaft, crank, connecting rod, right? So this can be performed in a single project. Okay, now observe under the model analysis, the first, that is first is type of analysis, right? Model. Then second stage you observe engineering data. Okay, so engineering data is nothing but the material or material properties you require to input. Then third step you observe geometry, so you have to require to create a geometry, or you can import that geometry. Okay, then you can look here, it is similar like showing meshing, that is modeling. All right, so conversion of FEA model, convert whatever the geometry is there, that we are converting into FEA model, that is with the help of node and element. So simply in this stage 4, what we are doing, meshing. Okay, step 5, setup is there. Setup is, you observe the two arrows are given on a geometry, one is red and one is green. So it will indicate the application of constraint or boundary condition. Load apply करायचा तुम्हाला, boundary constraint करायचा आहे. So that can be you do using setup. Now 6 stage is a solution. 6 stage is solution, and 7 stage is a result viewing. Result viewing. So you observe for every project that 6 to 7 step procedure is same, right? We already studied what are the basic step in FEA. We will import the or pre-processing, processing, and post-processing is there, right? So same that are classified into these sub stages, right? Or these sub steps, right? So you observe here engineering data, it is showing the check mark, right? In front of engineering data, initially you take any type of analysis, it will show for the engineering data by default it is check mark. Now under all others, under the geometry, model, setup, solution, and result, it is showing the question mark. It is showing the question mark. So what is the indication of this? So green mark indicate this step is complete. This step is complete. Now what about the engineering data? Engineering data is nothing but the material, right? Material. So by default, it will take as a structural tree. It will take as a structural tree. Suppose you can add this your new material from the engineering data source, right? Engineering data source. So there are under the general materials, the engineering structural steel is given. Suppose you click on general materials, now you can observe what type of materials are there. What type of materials are there? That is general materials. The titanium alloy is there, then the structural steel is there. You can observe the property of here, right? Density and all that things are given. Young modulus is given 2 e raised to 11 or 200 gigapascal, right? The units are also given. You consider the stainless steel, you can observe how the property is going to change. Density is changing, right? Young modulus is changing. You can consider the polyethylene, you can observe how this property are changing. You can consider the gray cast iron, you can observe how the property are changing. So these are the some standard materials are given. Aluminum alloy is there, right? Or RCC, concrete is also there, right? So depend upon the type of material you require, you just simply required to click on add to engineering data, add to engineering data. Similarly, there are composites materials are also there, right? So you can click on a composite material. You can observe, right? These are the composite materials are the epoxy carbon is there, epoxy glass is there, honeycomb structure is there, e-glass is there, right? So explicit materials are also there. So depend upon the which material you require, you can simply that add, right? You can simply add that material for your component. Okay. So you have to require to simply click on plus. You have to require to simply click on plus. It will take some time, right? AL is there. So composite hypermaterials are there, thermal materials are there, fluid materials are there, right? So under the general materials, we are considering the structural steel, right? Structural steel. You can observe the property of the structural steel, right? It is showing here. Poisson's ratio 0.3, Young modulus 200 gigapascal, bulk modulus, shear modulus, density is there, right? Coefficient of thermal expansion alpha is here per degree centigrade. So this is the values for the steel, right? You can, so it is providing a ready-made record. In classic you observe, you are required to input the property, but here already properties are there, library is given. So from that you have to select the material. You have to select the required material. Okay. So engineering data, under that engineering data is there. Okay. So close that. By default it is engineering material. Now geometry, for geometry I have ready-made file .igs file that can be import. So just right click on geometry. It is taking some time. So right click on geometry, right? You have to import the geometry. You have to import the geometry from the available files. .igs files are there, right? From there you have to require to import your geometry, whatever the type of geometry will be there. So lots of parameters that depend upon how the software will respond to your commands, and it is basically depend upon how the configuration of PCs all there. The RAM काय आहे तुमची, what is the processor speed is there, all that things. Okay. So generally you observe license version or the software which is used in industry, they are having a very high end. They require very high end uh, personal computers. Okay, that may be handling the 3 lakh, 5 lakh nodes. Mm? And it will take at least 8 to 12 hours to meshing that or to create that FA geometry, right? And also it will require a 1 to 2 day to solve that geometry, right? So you can observe the size of, or you can go through what is the size and all that things, It is not responding, I think. Okay. Now this is the your the pace or 2D CAD pace where you can create your own model. So the command are there, whatever the CAD commands are there, right? Simply you to right click, right, to open, or simply suppose you have a file, you can import that file. Okay. So circle is there, line is there, rectangular is there. They are the various commands are there. There are, right. From in that case, similar to the what you can say CAD. So you can create your own geometry here, or else suppose you have a file open, already there is file, you can already I have IGS files. Okay. So right? I am having a 3 to 4 files. From selecting the directory, I will open that file. Open. So it is importing the geometry, whatever the type of geometry is there. Okay, I am importing the connecting rod. So simply you have to open the file and call that file. Okay, in CAD or in this pace. Okay, or simply you can import from here project also. You have to require to right click, right, and import. Right click and import. Right. So this is your geometry. This is a connecting rod geometry. Right. So once the geometry imported, file uh, you can close, save the changes in the following item. Yes. Make the changes here. So whatever the geometry is there, that we have imported. Or you can simply right click, import geometry, browse, right? Connecting rod is there. So I will open that. Now you can observe when the geometry imported successfully, it will now showing the right check mark. Okay. Now under the modeling, it is showing with some circular arrow, or so it is under the process. So go to the right click on model, right, and click on edit. Click on edit. So it will open the modeler now. The new window is being opened. That is called as a modeler. That is called as a modular. So once you complete all the steps, or you complete successfully all the sub step, it will showing the with a green check mark, or it indicating the it is done, or it is whatever you have done, that as okay. Right. Now new window will open. This is your project window, right, and this is the modeler. Okay. This is your modeler. Right, it is uploading. Right, now this is your geometry, whatever the geometry is there. Okay, a connecting rod is there. Now you can observe here under the project we are doing the model analysis on the left side, or this is a tree, right? Project tree is there. Same type of tree you have observed in case of CAD softwares, right? Or while drawing the CAD file or project. Under the modeling, geometry we have imported, it is showing the details of file also, connecting rod, whatever the type is there, file name is there. Then under the material, we have selected structural tree. Under the Cartesian coordinate system, we have considered the global coordinate system. Okay, right. Now mesh, it is showing not completed. Also modeling, the analysis settings we have done has done, because we have selected the type of analysis model, and under the solution it is again showing the incomplete. So where the you can thunder like symbol is there, right? where these are the under process or not completed, right? So you have to require to that. First go to the mesh. Right? Element size. You can consider the linear or quadratic, right? Linear or quadratic. Linear is a lower order element, quadratic is higher order element, or you can use program control. Element size, you can give point not. Or suppose by default you right click on generate mesh. You click on generate mesh. By default it will create the free mesh. By default it will create the free mesh. You don't no don't nothing have done. The mesh is program controlled, or by it is a default free mesh. You observe under the statistics, it will show the number of nodes are 3131, number of elements are 1357. Okay, so these are the number of nodes and number of elements created. Suppose you require to change the element size, right? You have to require to change the element size. So I will give 0.1. These are the dimensions showing in meters by default. By default, you can change the here from here also units. Metric system is there, right? Then US is there, feet pound, angles on degree, rotational velocity, radian per second, temperature in Celsius. Okay, so whatever these settings are there, kept as it is. Suppose you want to do, required to do, to convert that in mm, you can convert that. Okay, so now I will change the element size, right? 0.01 mm, 0.01, sorry, 0.1 meter. Okay, and I will click on mesh and update. Right click, update. So automatically it will update the meshing. Automatically it will update the meshing. Right now you can observe the meshing change. We don't deleted the previous mesh. It is automatically in that geometry only. You can observe under the statistics, the number of elements are created is are around the 9,535, and number of nodes are 3,150. Okay, so this is a very flexible tool, right? You can at any stage you can revise your meshing. You can revise your meshing. Okay, so meshing is done. Now you can observe here the check mark is shown, right? Check mark is shown. Initially it is yellow thunder like symbol. Now it is showing the green, so it is completed. Now go to the modeling analysis setting, right? How many number of node you want to extract? Suppose you want to extract the 10 number of node, initial 10 number of nodes. Okay, so it is damped. You are saying no. It is solver type, is a program control. You have direct, iterative, unsymmetric, super mode, or subspace is there. So we will kept as a program control. Okay, number of mode to extract. Now solution, under the solution, insert deformation total, because whatever ultimate aim is, we are getting the 10 number of modes, and corresponding to that 10 nodes, what is the deformation or what is the shape of vibration of that connecting rod. Okay, that we are going to saw, we are going to saw. Okay, so solution required is the total deformation, and which is corresponding to node 1. Suppose I will add again, insert deformation total, right? And for the second deformation, I will assign a second mode. Similarly, insert again, I will insert the total deformation, and for that 3 nodes, I will assign third mode. Third deformation, I will assign the third mode, right? Insert deformation total. So whatever the number of modes are there, insert that much of deformation or deflection. You can also give the directional deformation also, directional, where you have to require to define the size along the x or along the y or along the z, what you require. Okay, and you have to specify the mode corresponding to that. So for 5, I will assign the 5 mode. For 6, I will assign the 6 mode. Okay. For directional deformation, you assign the 7th mode, suppose. Okay. So under that, you can assign insert deformation total. So for that, assign eighth mode. Okay. Then insert deformation total. For that, assign the ninth mode. Okay. So for every deformation, you have to require to assign that individual mode. So for ninth deformation, there is one directional deformation we have taken in between. Just view the result. No worry about that. Right. So this is the type of resolution what you require in solution that you have assigned. Right. So initially, before the solving the problem, you have to require to you are looking for the which result that are required to assign. Okay. So this is the deformation or 9 or 10 mode shape you are required, so that you assign. Now go to the analysis setting. Okay. Insert fixed support. So you have to require to apply the boundary condition, right? You have to apply the boundary condition. What we'll do, we'll constrain one face of the connecting rod here, or one edge, because this is a here and here we have pin, here we have gudgeon pin, here we have crank at the large end. So somewhere for only constraint purpose we apply the fixed support. So fixed support is there, right? What you require, suppose you require edge, so select the edge, right? And select that edge. Right. So this is edge you selected. You select with the help of control for the multiple edges, right? And apply. Right. Now two edges are there and fixed support is there. Right. Two edges are there, fixed support are there. Right. So it is showing fixed support. It is showing the fixed support. Okay. So very simple to apply the constraint. Now we will solve. Right. Go to the solution, solve. So it will solving. Right. Here you can observe the 10% is being there. Right. Look at the progress bar. It will take some time. Because the number of elements are more than 10,000 or around the 10,000. So it will show. Right. Now you can observe here all the green marks are there. So whatever the result you have required that are plotted successfully or that are processed successfully, now you can observe all the green marks are there. Right. So this will indicate there are warnings are also there. So don't go for that. Solution information is there also there. So this is similar to the whatever the output file which is being generated, right? Solution information. Now go to the total deformation. Now you can observe here. These are the 10 modes. There is mode 1, 2, 3, 4. This is serial number. 10 modes are there and 10 frequency are there corresponding to that mode. It is showing. So for first mode you have 4 hertz. For second you have 5 hertz. For third you have 15 hertz. For 4 you have 51. For 5 57 up to 10th mode you have 250. Okay. So this is the frequency plot. This is the frequency versus number of modes. Right. Now you have to look the result. This is corresponding to total deformation corresponding to first mode. Now you have to look for how this is going to vibrate. Okay. How this is going to vibrate. So here there is option is there. You can play. Right. Now you can observe. Right. Once you click on the play button, this is a pause. Right. And this is the play. So this is the first mode you are extracting with the frequency corresponding to 4 hertz. And you can observe this is the bending is happening for the connecting rod. Okay. Now look at the simply pause. Right. And click on total deformation 2. Right. That is just corresponding to second mode. Here you can observe, or this is second mode is being highlighted. Okay. Now click on play. Now you can observe. Now the direction of the bending is changing. Right. Now observe the third mode. Now you can observe here third mode is selected. Now you can get the twisting of the connecting rod. Okay. right? You can observe here also frequency is 15 hertz, frequency is 15 hertz, total deformation is 0.101, around 13 mm deformation होता है, right? 0.013 meter है, right? 0 to 30 minimum to maximum, right? Stop that. You can go to the 4, right? Observe the plane bending, so it is showing the maximum bending, right, at the mid portion, so this is the again different mode corresponding to which frequency, 51 hertz of frequency. Okay, go to the 5th, right? Now you can observe again, now it is bending in a different plane, so in this way you can observe the different modes, 6 mode, right? Now you can get the compression of the connecting rod, right? The plane of bending may be different. Okay, or suppose directional deformation is there, right? Now you can observe how this is going to deform, right? So it may cause the failure of the connecting rod near this region. Cursor this time. Why? So you can simply change the cross section to the solid or I section, so it is able to being strong for that mode, right? So in this way you can do the analysis and can observe what is the displacement is there, what is the shape of vibration is there, where you required to add the stiffeners and all that things, right? The 7th mode, right? Now you can get, right, bending is happening in a 2 plane. This is the 1 plane and this is the 2nd plane where the bending is happening, right? Now this is, you can, so ribs are going to twist, right? No, there is no effect in this region because we are not constrained here. Actually in practice it is constrained, so you can constrain at the both end, right? The frequency may be different, right? So you can observe the bending is there, so rib are going to fail, right? So in this case you can observe the corresponding frequency, and beyond the few hundreds there is a very large frequency are there, 156, 163, so that are not going to expose, so we are only limited up to 100, so 6 to 7 frequency are there that are only point of interest, right?